Well, hello, everybody. This is Sergio Pages, along with Tom Ray. Thanks, everybody, for coming to the Pavement Management Seminar, Avoiding the Potholes, the Secrets to Successfully Managing Your Pavement. Again, I'm Sergio Pages with Structure Tech, Senior Vice President with the company for about 27 years. And I have the privilege and honor of being here with my colleague, Tom Ray. Tom Ray, could you please introduce yourself?
Yeah, good morning, folks. Happy Friday. Yes, I'm the Divisional Manager for Structure Tech in the Civil Division with the Pavement Management Group. Got years of experience with the DOT specification committees in the past on the asphalt, concrete, and aggregates specification. I've attended Federal Highway Administration specification seminars as well. 30 years of experience. I'm glad to be here this morning and welcome everybody to the seminar. Thank you.
Well, needless to say, plenty of gray hair in this room, gentlemen and ladies. To start with, let's talk a little bit about the objectives for this webinar. And I would like to start by stressing what we advertise out there is that the objectives today are going to be, first of all, how to help you determine whether your pavement is a candidate for repair or if it needs to be replaced. That's a key question a lot of people ask. Okay, how should I go about determining what needs to be repaired and what's to be replaced? And then after doing that analysis, how do we prioritize and develop an index, a prioritization scheme? We're going to have a PACER system that many of us use across the nation. And then how to properly manage a pavement construction project. Pavement construction projects are challenging in themselves. They're fast burn and they need very close attention. And then lastly, how to ensure that you're receiving a cross-section with the lowest annual cost of ownership. And that's going to be key in this presentation, Tom. So let's start with one slide set that illustrates one key parameter that we all have to deal with, and that's the cost of the project. And to make a good comparison, a radical comparison, this picture that we have here is the very first concrete road in the United States, and it was done in Detroit, Michigan, on Woodward Avenue. And this project at that time cost a value of $13,000, and obviously the cost has increased dramatically.
Sergio, a lot has changed since 1908 in cost.
Correct. Yes. The other factor is loads. And we picked a very radical picture again here. And Tom, will you care to elaborate on this particular?
It's just this photo is to portray the extremes in loads on our cross-sectional design work. This is a flowboy tractor. In Michigan, they have a GVW maximum legal load that's 164,000 pounds or 82 tons. So with those 11 axles and 3 lift axles, we're carrying a little over 20,000 pounds of weight per axle, which creates stress and load on the cross-section.
Excellent. So going next to, hold on a second, I'm having difficulties here in my slide. It's not going. Hold on a second. Bear with me, gentlemen. Okay, the next slide, you can tell us a little bit of the story behind this, Tom. This deals with loads and the problematic if you don't calculate things right.
Well, it's actually on Jefferson Ave and River Rouge, and the real message in this photo was as a result of field quality control. There's a 48-inch pipe underneath that vehicle, and about half of the bell section was broke off. The contractor placed it as opposed to setting it off to the side, and with every storm event, it cavitated a little more under the pavement until there was a hollow spot big enough to accommodate vehicles in a fall-through. The only reason why it became self-evident is during the construction work that was going on Jefferson Avenue with all of the activity that in that process it weakened enough to allow a fall-through, which exposed the field quality control error with 48-inch pipe and the bell section being off, and the need to be on site watching the as it's occurring.
Excellent, Tom. So let's start with pavement evaluation. How do we assess the condition of a parking lot, of a road? So obviously, some key stats are you want to do a physical, visual condition evaluation, and then as well as doing some geotechnical data, doing some course in your parking lot or roads in order to understand both the visual as well as the underground information. So let's go through this process a little bit in more detail. So let's start with the surface evaluation. And Tom, why don't you explain the PACER process? Because it's a program that's been used nationally, and it's just a good model to follow.
It is, Sergio. From state to state across this nation, the PACER manual is recognized as a unifying tablet, if you will, descriptive to for pavements to be reviewed and categorized in a certain pavement index between 1 and 100. And each of the varying characteristics have 12, 15 characteristics that are described that says it is a 15 in pavement condition index, or a 50 or an 85, and it varies from very poor at the end of its life cycle to 100, which is a newly paved or newly constructed roadway cross-section.
Excellent. So for everybody on the line, this manual can be freely downloaded. This comes from the University of Medicine, and just about every transportation across the country uses it. It's a fantastic tool to be able to, if you have many lots across a portfolio, you can have your engineers use it to have a standard way of measuring the condition of the site. There's one for asphalt, there's one for concrete. And then the other piece of information that we need is soil borings, and there's an example of 3 locations on a drawing highlighting where we want the soil borings to be done. And then in the next slide here, we can see the output of those soil borings, and you can see the depth of the boring here, about 15 feet, and it tells you the composition of that surface, which is going to be critical in determining not only the condition of the pavement, but also in designing in the future. And Tom, you want to add anything to that?
Yeah, and there's certain stratus or spheres of substrate soils that have characteristics that are greater in terms of their stability and ability to handle a load, and lesser. So it's those kind of substrate soils that impact proper design cross-section, and also the static height of groundwater, where that elevation is below the surface of the pavement, has a huge impact on cross-sectional design work.
Excellent. And so now let's jump into some typical or common pavement deficiencies that an inspector will look for. The first ones that we're going to look through is the typical cracking that we see on pavement. There's an example, a close-up of a cracking. Here's another example of a traverse cracking, typically due to freeze temperatures. Here's another example, more of a traverse cracking on a parking lot. And as you can see, there's vegetation growing already. And Tom, could you elaborate on this particular slide on how this can actually create a longitudinal cracking as well?
Well, what I would like to portray in this photo is an offsetting of the joint lines from base course to intermediate course to surface course. So a 2-foot offset, just so that you don't stack those joint lines on top of one another, which allows a far greater propensity for that joint to open up, and then stormwater penetration down into the substrate and the aggregate below, which just aggravates and minimizes the life cycle.
Another type of deficiency that you want to look for in a parking lot is rutting. And we picked up a pretty interesting story here of rutting. This is at the entrance of a utility company. And tell us a little bit of what we see here, Tom.
This is a major utility company in the Midwest. And as the company obtained more property to the east of the original piece of property, they decided to move the main entrance to accommodate a more fluent flow of inbound and outbound vehicles. They happened to put this right over top of where they buried all of the stumps from the original site development some 22 years before this relocation. And the wheel rutting, there's the wheel rutting. That was a depth of 9 to 11 inches, and it was really as a result of an entrance road being put right over top of organic that was below it. Now, the solve was undercut, engineered fill, bring the cross-section back up with density, and stop the wheel rutting settlement.
Excellent, and that's a dramatic case, but probably the most common one is the one that we have here, which is between typical wheels that create rotting on your parking lot as well. So, okay, let's go to the next group of types of deficiencies, and this is the one that we are most familiar with, the typical potholes. And obviously, when we see these types of situations, you're basically at the end of the service of those areas, and therefore you're going to need some very stringent repairs, and perhaps if it's more than 20%, you might as well replace the whole area, and that's a sign of considerable damage there. And then the next group is the alligatoring. Alligatoring is usually very much a telltale sign of just the structural integrity of that parking lot has just come to an end, and it's time for replacing it. Many times you see people trying to coat it, seal coat it, and that's just a waste of funds because you just cannot rejuvenate that type of thing. You usually are due for a replacement. Here's some additional close-ups of that type of alligatoring that gets pretty dramatic. And then jumping into concrete, typical concrete damage. This is, I'm going to go to the next slide so you can see another perspective of this, but this is typically where a dump truck, for example, will do a significant job. And Tom, can you remind us a little bit of that?
Well, in the background, you'll see a scrap bin, okay, and it was filled with, in this case, scrap metals. So there was a lot of weight to it. But when it is picked up and the empty ones dropped off, there's about a 2-foot drop when they disconnect to push this thing back into place. and it's that impact loading that did tremendous amounts of damage. So there's engineering and design cross-sections that have to accommodate those kinds of loads and impact loads.
Excellent, Tom. And then, of course, this is a typical example of stalling on concrete. So once you do a visual inspection and you did your geotechnical, you can put together a program for that site. And this is an illustration of a drawing showing the different P sections. The site was divided into different sections. In this particular example, we have about 13 sections, and the colors delineate the different ratings that were given based on the PCI. So anything that's red is in poor condition. Anything that's in green is in excellent condition, and that gives you a roadmap for what the next steps are for that particular parking lot. And then here's just a graphic illustration of the PACER results. As you can see here, 39% is in very poor condition. That's likely where you're going to start spending some capital. Anything that's fair and good condition, that's most likely where you're going to spend some maintenance dollars. And then the next screen you can see is the budgets that have been developed based on the conditions manual. You basically develop a 5-year plan based on unit pricing for that particular area that you're at. That way you have a roadmap for the site for each year, requesting funding for the different P sections. So that kind of wraps up the first part of this presentation, dealing with the evaluation of a site. How do you assess it? Now we're going to jump into the design. And in order to do the proper design, the proper solution for your site, we need to consider these two considerations. Number one, how do you design a pavement project that will provide you with the lowest annual cost of ownership for your site? We want to make sure that we're spending the right amount of money and it will last as long as possible. And then what are the inputs necessary for designing the right pavement fit for the purpose of that site? So there's a lot of information that we need to collect, and basically we can summarize it into two key components, two inputs that we need. First is traffic. We need to know about the volumes, the types of weights that are coming in. And then, as we mentioned earlier, based on the soil borings, we also need subgrade support. What is the data about your site? So let's start with the traffic, Tom. In the next slide, it illustrates basically that we need information about volume and the weights that are coming in, okay? So using this illustration, let's introduce our audience to the easel theme, and why is this important in designing the right section?
Easels are a standardized unit of measurement for design criteria, and it's the equivalent single axle load. And nationwide, it is established at 18,000 pounds, okay? And that's a single easel at 18,000 pounds. Now, on a semi-truck tractor, for example, if it's a big Kenworth with a lot of motor weight over that steering axle, for example, the very lead axle, it may be 34,000, 36,000 pounds, which constitutes two easels or two increments of 18,000 pounds. It's that stress over a concrete cross-section or an asphalt cross-section that reduces life based upon the load and the volume.
Excellent. And now let's talk a little bit more about the subgrade part of this of the picture here. So in order to discuss that, let's jump into the what it's called in the industry the California bearing ratio. Could you elaborate on the CBR?
CBR ratios is the ability for any substrate material or aggregate base or cross-section material to withstand a load over time. Okay, and for example, in this photo, it indicates and refers to a plowed farm field, which has a CBR ratio of just 3. Now, moist clays are 4.5 to 4.75. Quality aggregate bases, and by that, if you were in Ohio, it would be a 304 base, or in Michigan, a 21A. Their cross-sectional CBR ratios are closer to 80. Get into asphalt and concrete, you're now in the mid-upper 90s and encroaching on a CBR ratio of nearly 100.
Excellent. So now let's show you this illustration to kind of visualize the easel impact. So as you can see on this slide, we're showing you the different calculations for easels. In the very lower side, you have a typical lightweight vehicle. The easel factor is only 0.0007. Okay, so those vehicles have not as much impact on your parking lot. Once you get into a delivery truck, your easel factor goes up to 0.1, and then when you start getting 18-wheelers coming into your site, you got 1.35, and then for illustration purposes, we used a loaded 4-inch bus at 1.85 factor. Now, all of this plays into that cross-section design and based on volumes that are coming in. But Tom, you want to add something to that?
Sergio, just a point of interest. That 1.85 for the 40-foot bus tells us a story. The gross vehicle weight of that bus is 33,300 pounds, which is 1.85 easels at 18,000 pounds gives you, so you can work the numbers both ways.
Excellent, excellent. So as we continue, you can see here's an example of a calculation for a particular, just a very simple parking lot where you have 3 different types of vehicles that we're illustrating here. We have a 3-axle single units. We have 25 vehicles of this type that are coming daily. And those have a 0.8 factor, easel factor. So you can see the dailies are 20. You have the 3-axle semi-trailers. That's a 0.5. 15 of those come in. And then a 3-axle factor semi-trailer. So the for dailies is 47.5. Okay, so you take that 47.5, you multiply by the number of days in your year, and then you determine how many years you want your investment to last there. So we're assuming here 20 years. So you're designing for 346,750 easels. Okay, so that's the parameters that you need coming in terms of preparing a cross section for that is fit for the purpose.
And there is some extremes. Easel counts, for example, at a distribution center owned by Kroger Corporation down in central Ohio, where you total the number 25, 15, and 10. That's 15 exposures of semi-traffic per day. In the distribution center in Ohio, the easel count annually was 29 billion.
Wow.
Which means tremendous amounts of semi-truck traffic and loads coming in and out of that distribution center from dock areas.
Yeah. So to illustrate the point, we took this statistic from from a study that the Wisconsin Asphalt Pavement Association did. The impact of one heavy loaded interstate truck is equivalent to 5,000 vehicles. So that's why it's extremely important for you to understand the type of traffic volume that's coming in and doing these calculations prior to starting your design.
The volume and the axle stress that it exposes the pavement cross-section to all equates to the life cycle or lack thereof based upon traffic.
Exactly. So bottom line, you want to have the right easel count prior to starting your design. You want to think about the time that you want that investment. If you're going to put $300,000 in your parking lot, $1 million, whatever that number is, you don't want to look at just the first cost. You want to look at the long-term investment there, and that's why the performance and the type of stress that you're going to put into the parking lot is extremely important to determine that. So that's in respect to the axle weights and traffic, Tom. But let's jump into the other part that is very important, and that's drainage. You know, you have to have, obviously we need to know the soils there, and then the other factors about drainage. So can you elaborate a little bit on this, Tom, in terms of drainage, the importance of understanding the proper drainage requirements for the site?
Yeah, it's grade and slope on the surface, of course, and then some of the drainage issues are storm drain inlet structures, the spacing and the pipe size diameter to handle a 10-year storm or a 20-year storm. And equally as important is substrate edge drain in order to get the water out from under the pavement cross-section and out of the substrate below the pavement. All of that enhances the life cycle length and reduces the annual cost of ownership, which is the goal.
Tom, and you have mentioned the relevance of edge drain requirements for northern states.
Well, it's a direct reflection of deep freeze and thaws, and it's not uncommon in latitude 45 areas that frost can go as deep as 60, 70 inches at some times, and this particular winter was an extreme one because there was times minus 10, minus 12, minus 18 for a sustained period of time, and that frost heave that occurs as it warms up in the day and freezes down again at night creates a lot of pavement stress and reduces life cycle.
Excellent. So next, we talked about the CVR, but Tom, you're a big proponent of what is called in the industry the E18 study. Could you share with the audience what's the relevance of that, and how does that help them?
E18 cross-sectional studies are accepted as the design criteria at most DOTs in states of nation, and it's taking a number of different moduluses or impacts. It's the kind of soil that you have, and it has certain CBR ratios that have certain numerical components, and we just mentioned the farm field versus the crust agate and where that falls in place. So they each have a numerical value that drives for that sweet spot, the cost-effective cross-section to be fit for the purpose for the type of traffic, be it real heavy semi-traffic as in the Kroger distribution center or an employee's parking lot with just automotive traffic. The E18 study is the backbone to making that right decision engineering-wise.
Excellent. Thank you, Tom. And then moving on, let's give you an illustration of a payback so that you can see the analysis. In particular slide, we're showing an existing pavement that, the way it was designed at the beginning, it had after doing this analysis, it had a fatigue years of 13, rotting years of 3, and cost per square foot was 2.2. So bottom line is an annual cost of ownership of that particular situation at $63,000 per year. What was designed here or suggested, part of the suggested for this particular site was improve that thickness to 3 inches on the base and 2 inches in the subsurface, and that change will provide the owner with an annual cost of ownership of $47,000. And then we also included an alternate bid with some cement treatment that increased the annual cost of ownership, or decrease it, I should say, to $14,000 per year. So that's very relevant, Tom, in terms of doing the proper study to determine what's the best annual cost of ownership when you're making these decisions.
Right, and Sergio, if you would, I'd like to jump back just to capture an extreme, okay? Let's jump back one photo. Mm-hmm. This is a mill and fill cross-section that happened on one of the projects that we dealt with one of our clients. And the life cycle proposed based upon the E18, and that's integrated with the traffic, the volume, the axle weight. And if you were at the Kroger location under that kind of stress, the projected proposed life cycle was 21 days.
Now, so 21 days before it starts failing. Wow.
Before 20% failure of the cross-section. Mm-hmm. Now, backing back into life cycle cost, that equated to $15.6 million a year if you kept up that practice of just mill and fill, yeah, and expose it to the kind of weights that were involved. So proper engineering is being cost effective.
Excellent. So the message we're trying to get across is, having the right pavement cross section that fits the purpose of your site is critical. And then part of what we want to illustrate here is also some examples of cross section. This is for heavy duty, and on the left you see the typical asphalt design. And on the right, you have a more of a typical concrete design for heavy duty. And then on the next slide, we have an example of a light duty cross section. So as you determine your traffic loads, you can pick one of these, and every state has a particular DOT standard, mm-hmm, so you don't have to recreate the wheel. This analysis has been done. And all you have to do is match the results for your particular site and adjust the cross-section that meets your particular situation there. So.
And Sergio, the whole point is the E18 will back into cross-sections that find that sweet spot, the most cost-effective way of doing it, to ensure the lowest annual cost of ownership and get the right cross-section price-wise.
Excellent. Then, so bottom line, and the objective of a good design is to reduce the annual cost of ownership and ensure the full life cycle cost or duration of that investment. Other considerations, should you use concrete or asphalt? And that's what HMA stands for. Concrete is typically ideal for loading dock areas, the perimeter roads, dumpster facilities, but obviously it costs usually 3 times more than HMA. HMA is good for employee parking, automotive traffic only areas, and obviously the cost is more reasonable. Other considerations in terms of means, methods, and procedures, we'll illustrate some examples here. Here's an example of on the top part of this slide where the entire site require a significant investment, and many of us have been where we are requesting $1.2 million for a complete project, and we only get a fraction of that. So how do you allocate that? So what you see on the bottom of the screen is an example where instead of getting the full $1.2 million, we only got maybe $150,000, $200,000 worth of budget. So we were able to do a portion of it. And that's what you see in the middle on the bottom slide.
And Sergio, this is a 5-point intersection with a tremendous amount of traffic on it, and with the constraints applied to the available budget, one has to do the priority areas first, and that's the alligator areas that are starting to displace. Had it not been repaired, most of that intersection, the snowplows would have piled up in the corner of the lot before.
Yeah, a difficult question I get asked, okay, Sergio and Tom, so I only have a little bit of money, I'm doing this portion, how do I connect the old with the new in order not to compromise that. And this next slide illustrates the detail that can be used for those type of connections so that, there's good interface between the two areas.
And that's a joint detail, Sergio, that allows no degradation of the vertical part of it. And it also goes back to not stacking the base and the intermediate and the surface on top of one another. It has to do with that separation and distance to ensure no opening of that longitudinal joint.
Excellent. And another consideration is concrete. Here's an example of a concrete project. And we just wanted to illustrate the importance of, in the design, incorporating the right type of rebar as an example. And Tom, what's the impact of using epoxy-coated rebar versus...
Well, epoxy-coated is, and there's a lot of studies on the OT levels that support this. It's a little more expensive than that of raw bar number 4, but the number 4 will, without the epoxy, will have a tendency to rust. And if it's established in the concrete 8-inch mat at the midpoint, then on a 12-inch on-center grid, that rust has a tendency to cause a separation shear point due to volumes of ESO load. It's that stress, that down pressure, that causes the 8-inch slab to separate in the middle. A lot of problems occur along this line on bridge decks as well. So epoxy-coated number 4 bar 12-inch center is a lot less expensive than galvanized, but way better than just raw rod.
Excellent. And here's an example of just the joints, offsetting joints and very good stacks. In terms of the pavement, anything you want to add to that, Tom? Or
no, it's just it really helps to have that one design detail cranked into what's required by the construction crew when they're doing the capital improvements.
Excellent. Another option that's being used quite often, is an example of many parts of that, is to use cement stabilization.
Portland cement stabilization.
Yeah, Portland cement stabilization. Benefits, advantages of that approach, Tom?
Well, it's like a non-reinforced concrete, if you will, and it has certain characteristics that are extremely beneficial. One is the cost. In terms of the extended life cycle, it's a very cost-effective cross-sectional addition under heavy volume and heavy axle weight load. So if you run the addition of the Portland cement cross-section to your E18, you will see obvious, huge improvements in the overall life cycle in the endeavor to get to that sweet spot where it's most cost-effective in yielding the lowest annual cost of ownership.
Yeah, so it's a good option for a lot of people who want to get a stronger cross-section but not necessarily have to spend a lot of money on it. And then jumping into milling, this is an area that a lot of people miss, Tom, but explain to us what are the advantages of milling?
You're actually taking a facility asset, okay, a corporation-owned asset, and it is a green item because it's reusable. In Michigan, the liquid asphalt cost has went from nearly $900 down to, I'm going to use an average of about $600 a liquid ton. Now, if the liquid goes into that ton of mix, which is your fractured 100% fractured all 4 sides crushed stone that meets a certain specification, if it goes into it at the rate of 6%, and it's at $600 a liquid ton, then you still have an asset value of at least $36 just the liquid. And there's another $6, $8 worth of crushed stone that is also in there. So When it's milled off, after its life has expired, okay, and it's an alligator cross-section that is unsuitable for handling facility parking and the flow of traffic, then as it goes back to the plant, it has value. And in our bid documents, we add a facility-owned asset, the recycled wrap material, as a credit to the bid, because the manufacturer at the asphalt plant is going to reuse that product. Now, when you have that in hand and it's a value, it becomes a part of a deduction off of corporate taxes due at the end of the year as a result of a green recyclable asset that the corporation or the entity has. So we find the recycled material to be extremely valuable when dealt with properly and how it's presented in your bid documents.
Excellent. Good. So now that we kind of talked a lot about different design considerations, let's jump into the construction documents. How do we put together a set of specifications that will allow us to have a good, non-problematic project where you have good specifications, you have a good contractor that has bid this, and you're comparing apples with apples, and they're bringing the right mixes and products into the project. So good specifications, they have to be very clear about the scope, and we'll illustrate some of that. We recommend that you use the Construction Specifications Institute format, CSI format, and then ground those specifications on your state Department of Transportation specifications. That way, everybody that's coming to bid your work is going to meet those standards. Make sure you're incorporating E18 calculations, and then put the bid documents to a very qualified list of contractors. So, and speaking of contractors, we recommend that you have a plan to incorporate strong FQC or field quality control with good monitoring and administration during the project. Many of us know that paving projects are very fast burn. They last sometimes a week. You can spend $1 million easily, or 2 weeks. So the intent is to introduce in the construction documents the importance of having a qualified person observing this all the time. We'll elaborate a little bit on that later. This next example of an excerpt of the specifications is illustrating what we call section 400 from the construction manual. And Tom, would you elaborate on the different line items there that you see on the side and the definitions of those items there?
Well, all of the line items are a direct reflection of the DOT standard manual for construction, so it ties back into the DOT specifications, and each line is describing a different scope of work and describing the volume or the quantity of that work so that all of the bidding contractors are on the same page. Now, it's also beneficial to add some alternates at times, and the alternates give you hard numbers for additional costs that may or may not be able to be completed if the budget is not there to do so, but it provides the facility those budgetary numbers without an obligation to award.
Excellent. And then another excerpt from the project manual is the summary of work, and the summary of work typically it's what it says, it's a summary, even though the document might be pretty extensive. This summary illustrates the key highlights that we're expecting the contractor to fulfill as they're bidding this project. And then next we get into some of the specific technical details of the project manual. For example, in this section, we're highlighting the asphalt requirements. And again, following the CSI standard, the first part of this is the general information about the asphalts. Then we have a section that talks about the products, and we have aggregates, the different types of asphalt materials that we're expecting. And then the mixes, they're very specific mixes that we're going to ask them, and we're going to reference them, tie them into the specific state the DOT standards so that those mixes are going to match with every contractor that's going to bid the job. Finally, as far as the construction manual, we want to include a site map, and this particular site map illustrates the different scopes of work that we're expecting the contractors to do. So it's a drawing illustrating where the work's going to be occurring. In this particular case, we even put some items that are year specific. And then, of course, we want to know details. This illustrates the cross sections that were defined. Again, doing all that homework that we mentioned earlier. The E18s, the ESO calculations, the weight, traffic volumes gave us this cross sections for this particular site. Here's an example of a restoration layer, and then finally here is a
storm drain inlet structure.
Exactly, part of the drainage aspects of the construction manual. So once we have a very solid project manual that we're going to submit to the bid event, we set up the bid event, and of course, your job is only as good as those contractors you're going to invite. So it's extremely important that you invite proven, paving contractors. And many of us are in situations where we barely do paving projects. So how do we tap into good contractors when we're not doing these type of projects all the time? So what we highly recommend is that you tap your particular state Department of Transportation. They have a very accessible list of qualified contractors. You may think, well, they're not interested in my projects because I don't have large highways. You'd be surprised. Many of these contractors have a lot of other divisions that are very specific to dealing with parking lots and projects similar to what you're likely looking for. So it's important that you invite a good, solid base of contractors. You want to make sure you qualify them up front. Here's an example of a scope review where we go into a lot of detail on the specifics of the project, make sure there's a clear understanding, and then you review that during the pre-bidding. And then once the bids come back in.
Just real quick,
sure.
Scope review is very important. After the bid event is completed, you have a vetting process to make sure there's no errors and no omissions.
Excellent.
And
thank you
for change orders.
Yeah, good reminder, Tom. And then once you get all the bids in, you prepare a bid recommendation letter after you have vetted all the contractors. And although I apologize for the fine print, but we have essentially 6 contractors that bid this project. And what you see as lines or as rows are all those Section 400 that we mentioned earlier. Again, all contractors bid this job, and you're comparing apples with apples. Every line item that was on the specification is listed here, and we can then compare one contractor against the other. You may even find that perhaps the low bidder has higher, and that might be a reason to pick them in some area and determine what's the who's the right contractor for this. Okay, so as we start wrapping it up, the last thing that we want to talk about is what we like to use the term trust but verify. So we did all our work. we did a great design, we have great contractors. You're not just going to let the project go on its own now. You want to have a good process to monitor, and we're not talking about quality assurance. This type of work you have to monitor. You have to be constantly watching how this is working. So first you start with a good pre-construction meeting. A good start is a good finish, so we highly recommend that. You want to set a series of progress meetings throughout the week, make sure that there's clarity on the work. And then we want to have safety meetings. I mean, we're dealing with very heavy equipment, high propensity for issues that could come up. And I know Tom likes to use the term safety huddles every morning.
Yeah, every morning. And that's to keep everybody's eye on the ball. Watch out for one another as if you're a family. And that buys into the culture for good safety and no injuries. And it's pretty much so a national endeavor anymore. And, to say we've over 400,000 hours of manpower work without injury, that doesn't mean that you haven't had some close calls, but you huddle up and talk about those near misses to make sure everybody stays aware and on the lookout for not only themselves but their workmates to make sure no injuries occur.
Excellent. So in regards to the site visits, what is it that we do when you're visiting daily the site? How do we trust and verify? So essentially, for example, we want to check the yield and densities. We want to check the thickness of the HMA, Tom, and then we got to check the thickness of concrete, check the temperatures, quality of mix, and then do samples of the types of materials that are coming in. So Tom, anything you want to elaborate? For example, in this next slide, I'm going to show a plant. How does the plant
that's
paint
a transit mix plant that's putting together your curb, sidewalk, walkway, concrete approach, and concrete cross sections. And I'm suggesting that you go to that plant before the pour starts, get a hold of the plant operator, make sure that they've got the right mix design and that it matches up with the submitted mix design that was approved. And same goes true with the asphalt plant, which is what we're looking at now. Go to the plant operator, and he will be in the control tower. Make sure that his mix design matches the approved mix design that comes out to the job. Far, far better to catch a mix design error at this point. 300 or 400 tons is actually on the job, and it's the wrong stuff.
Excellent.
It's just one part of field quality control that is essential.
So Tom, as I go through some of these last slides, what are some of the things that you are encouraging our audience to watch
during construction? If go back to this one, if you could. As the material's coming out from underneath the screed on the paver, typically is about 68 to 72% dense. Then behind this crew is a whole fleet of rollers that is adding compaction and density to get it from 68% up to 96%. The loss by compaction is at least 1/4 of an inch per inch. So if your design cross-section requires 3 inches, what's coming out from underneath the paver needs to be close to 4 in order to get from that 68% up to 96%. So one of the main things to watch in the application of construction activities on your capital improvements is depth, to ensure the yield is there, and yield is there. In the absence of it, your life cycle is reduced radically, and your annual cost of ownership increases tremendously. So field quality control and that oversight is essential.
Excellent. Okay, so as we start wrapping it up, we obviously want to stress the importance of making sure that you're verifying the work, ensuring that the crews are following the specifications. As you can see, the individual here with the orange is watching, is monitoring things, ensuring that the things are being performed according to the work that was asked for the contractor. And then lastly, measuring things and doing the material testing. We highly encourage, just like any other DOT project, that part of the work you include a material testing company that will be testing all the different types of products that are coming in, the different mixes. Without the proper testing, you can't verify if things are being installed properly.
Well, and it's a little deeper than that, too. If the test results show that the mix design is out of spec, then it can go into range 1, 2, or 3. And as that applies to the contractor and your budget as a facility manager and your payment to the contractor, it could go into range 1, 2, or 3, in which case it's reduced by 25% because it's range 2 with consistent errors in the mix design. It could be 100% where they've got to come in and mill it off and replace it, and that is consistent with proper specifications. Excellent quality of job.
Okay, so we finished the job. We put together a final report that encompasses everything that occurred, and then you install a warranty audit. We highly recommend that you audit the work a year after. Most of the time, nowadays we are able to get up to 2 years of warranty. So if you have an auditor that's checking the work in the first 2 years, you can actually have the contractor come back and fix any issues that came in as a result of weathering or drainage issues, workmanship. So auditing the work in the span of the warranty, which is usually 2 years, it's a good practice. So as we wrap it up, we're going to go over some questions that came up through the presentation. And just so everybody knows, this presentation will be available later. So you can look at it, read it, or listen to it at your leisure. But first question, Tom, that I have from a gentleman in the audience here. In your opinion, what is the most impactful thing that I can do during a pavement construction project?
Your state DOT specification will catch you far and away the greatest amount. That will have the greatest amount of impact. There is a huge difference between commercial mixes made on the HMA or the hot mix asphalt side. There is a huge difference in 2,000-pound concrete versus 4,500-pound, and it's making sure that it ties in specifically to those DOT specs. And having somebody on the job to make sure that 3 inches compacted ends up being the full 3 inches, because it has such a massive effect on the overall life cycle. If they remove a 1/4 of an inch from the base course and a 1/4 of an inch from the surface course, could cut your life cycle cross section in half. So it just is a lot of tons that they bid on and should be putting down and are not.
Excellent. Another question here. Tom, how can I ensure I get my recycled asphalt credit?
It's got to be a part of the bidding document. It's got to be a line item that says, okay, I have 56,000 square yards of material. I'm taking away 4 inches of asphalt. You equate that into the tons, and that becomes a credited unit per ton. So you may end up with $40,000 or $50,000 worth of credit, And I've seen these credits be as high as $12.50 a ton. Now, we know that there's $36 worth of liquid in there, but we also know that there's some milling cost, there's some trucking cost, there's some resizing cost before the plant can get back to reusing that material. So the average amount seems to be around $10, $12 a ton on credit. But if you got 4,000 tons on your project, then all of a sudden you're looking at $40,000, $50,000 that enhances and reduces the budget constraints on that job by that amount.
Excellent, Tom. Last two, how should seal coating be managed?
I'm an advocate of, proper maintenance. It's relatively inexpensive. It reduces the oxidation of the mix. It keeps more flexibility in your hot mix asphalt, and thereby gives it a longer life cycle. And I believe in its application, it should be done about every 3 years. If it's roadway sections, it certainly is no greater than 3 years because it will wear off. If it's parking areas, it could stretch out to under the vehicle and be as much as 5. So somewhere between that 3 or 4 years, seal coating needs to be redone.
Excellent. And then last, how do I hold the contractor to a warranty?
Just make sure that he gives it to you in writing for that 2-year time. And a lot is happening on the DOT side where these warranties are going from 1 year to 2 years, 2 years to 5 years. As the polymer mixes and the cost of these materials increase, the warranty is stretching out, and you need to get it in writing and then review it annually for any excessive raveling of the surface, for example, or excessive blowout of the concrete joints, because all of that has to do with workmanship as well as materials.
Excellent, Tom. It has been a pleasure working with you on this presentation, and appreciate everybody signing up. We had over almost 100 people sign up from just about all 50 states. This is pretty amazing. So congratulations, everybody. Thanks for coming. It's exactly the time to wrap it up. We appreciate it. Good luck and good management on your projects.
One more thing, if there's additional questions, feel free to send them in even after the meeting.
Excellent. And you have the information to contact us. We're always available. Thanks, everybody. Bye-bye.